Hello students, in this video we are discussing Cbse class 10 Maths NCERT textbook first chapter, that is real numbers, theorem 1.4. Already in the previous videos I have discussed the theorem 1.3. Now we are going to learn the theorem 1.4. So what does theorem 1.4 talk about? Theorem 1.4 is a very simple theorem which says root 2 is irrational. It's going to be completing very simple, that root 2 is going to be irrational. So what is irrational? We've already learnt about rational and irrational numbers. So we know that rational number, if you want to know what is a rational number, we already learned rational number is 1, which is going to be a number written in a fraction as a and a by b, provided b is not equal to 0. Here we want to prove that root 2 is irrational. Okay, so for proceeding with the proof, we are taking an assumption, and that assumption is that we are going to take a contradictory statement that root 2 is rational. So first we are trying to prove that root 2 is rational. If we are unable to prove, then it means that root 2 is irrational. So this is a method of contradiction. So you can say that this is a proof by contradiction. Okay, and now we'll get into the theorem. Okay, so first, now what is our consideration? Our consideration is that root 2 is going to be rational. If it is going to be rational, it means that I can write root 2 as a fraction of a by b, provided b is not equal to 0. Here in our textbook we are going to take the integers as r and s and not a and b. Okay, and we are taking the integers r and s such that, okay, we are going to take the integers r and s. The r and s can have a common factor other than 1. Okay, we are going to take r and s, and we are considering that r and s may have a common factor other than 1, but it is not necessarily that it might be there. Okay, so if we have a common factor, that means if I am going to take 10 and 20, you can say the factors are 2, 5 and 1. Also for this you can say that you can have 2, again another 2, so you can have 5, and then you have 1. So here you can see a common factors other than 1 is 2 and 5. Okay, in that way we should not have. So in this case what we can do is, so your common factor is going to be a multiple of 2 and 5, that is going to be 10. In that case you can divide and then you can take. So that is what we are seeing here. Suppose r and s have a common factor other than 1, then we will divide by the common factor to get root 2 to be a and b. So where a and b are going to be co-prime. So they are trying to tell us that root 2, when we are writing it in terms of fraction as a by b, then it need not necessarily be a co-prime, but we are going to dividing it by the common factor, and then we are going to bring it to be a and b such that your a and b are co-prime. Okay, a and b are co-prime. In that case we can write root 2 is equal to a and b. When you multiply this here, you will get it to be b root 2 is equal to a. b root 2 is equal to a. Okay, so here when we square it on both sides, okay, so we will square here as well as here. So you will get a square will be equal to 2b square. A square is equal to 2b square. So you've got one to be a square is equal to 2b square, and then you've got another one to be that is a will be equal to root 2 into p. Okay, so in this case, so we've already learnt in the theorem 1.3 that when we have p to be a prime number, then p divides a square. P divides a square. So here you can see from this that From this you can draw a conclusion that your 2 divides a square. I told you the meaning of this is that a square is divisible by 2. A square is divisible by 2. Okay, if a square is divisible by 2, then we can also say that a will also be divisible. Okay, a will also be divisible by 2. Okay, that is what we are going to see here. When we are writing it like this, 2b is equal to a square, then 2 divides a square. So by the theorem we can say 2 divides a. Okay, 2 will divide a. So instead of taking this, I am going to take another thing. So look into my next consideration. So we've already written that 2b is equal to a square. Okay, so now I know that if a square is divisible by 2, I know that a is divisible by 2. If a is divisible by 2, I can write this to be a is equal to 2 and some c. C is some integer. So from this only we were able to say that a square is equal to 2b square. Okay, here we are writing similarly, writing a is equal to 2c. Okay, so we already know that when a is equal to 2c, we can say that my a square is equal to 2c the whole square, where I will get it as 4c square. Now compare this and this. The left hand sides are equal. So let me equate the right hand side. So what will I get here? 2b square is equal to 4c square. So b square is equal to 4 by 2c square. So which will give me b square is equal to 2c square. So now with this what can I say? I can say that 2 divides b square. I can say that 2 divides b square. So I can also say 2 divides b by the theorem 1.1 again. Okay, see here we said that 2 divides a square. Okay, likewise we are telling here 2 divides b square. So if 2 is dividing both a square and b square, see, if 2 is going to divide both a square and b square, then it means that 2 is a common factor of a and b. Because if 2 divides b square, it means that b square is divisible by 2. It means that b square is divisible by 2. If b square is divisible by 2, then what can we say? We can say that both a and b are divisible by 2. See, we say that b is divisible by 2. So we can say that a and b are divisible by 2. If a and b are divisible by 2, then this shows that a and b are not co-prime. A and b are not co-prime, which is going to be contradictory to our assumption. Which is going to be contradictory to our assumption. So this is wrong because we have considered a and b to be co-prime. So in this case we see that a and b has another factor other than 1, so it is not co-prime. So in this case we say that our assumption is true, is false. If this assumption is false, then it means that root 2, considering it to be rational, is also false. If this is false, then we can prove that, or then we can say that root 2 is rational. Hope you understood this. We'll again look into what is given in the textbook. Okay, so 2b square is equal to a square. So 2 divides a square. So if 2 divides a square, then 2 divides a. Okay, so if 2 divides a, then I can take some integer c and I can say a is equal to 2c. So I have a is equal to 2c here. So now if you find a square, I will get 4c square. I have already have a square to be 2b square. I am equating these both. So from this I am getting b square equal to 2c square. From this we know that 2 is dividing b square. If 2 divides b square, 2 divides b. Then a and b has at least 2 as a common factor. Okay, but we have considered that a and b have no common factors other than 1. That means we consider that a and b are co-prime. So now we have a contradiction here to our assumption. Okay, so due to this, our assumption root 2 is rational is going to be incorrect, and thus we are able to conclude that root 2 is irrational. So similarly, we have our example 9 also, that root 3 is irrational. So example 9 says that root 3 is irrational. You will be following the similar steps. Okay, likewise in your exercise 1.3 you also have that root 5 is irrational. So these two are similar to the same proof. Okay, so hope you have understood this theorem, children. So with this you can do the example and the exercise sum which I have told you. Please go through the video again if you have any doubts. Also go back to the previous videos in order to understand what is a rational number and about the theorem 1.3. Thank you children. See you in the next video.